Hello friends, today we are going to discuss the motion of a satellite around Earth in an orbit. So to treat dynamics of bodies in physics, it's usually an approximation to treat the extended bodies as point particles at their center of masses. So the satellite of mass ms can be treated as a point particle at its center of mass with mass ms. Now, the distance ds remains the same because satellite in comparison to Earth is not going to be really huge, right? It's like an insect in front of us. So it's going to be small. So the ds remains the same. It doesn't change a lot. However, the center of mass of Earth is going to be at the center of the Earth. And here, the radius of Earth is going to be quite significant as compared to ds. So, so Earth can be approximated as a point particle of mass me at the radius at the distance re from the surface of the Earth. So the total distance between the two point particles now is r. This is something we should always keep in mind while solving any problems involving satellites around Earth. And the center of mass concept is important because there can be variations of a problem where, let's say, rather than Earth, you got a funky planet shaped like an 8, or maybe shaped like an other irregular objects. So in that case, you can find the center of the mass, readjust your distances, and still be able to solve this problem. Now, let us look at dynamics of orbital motions around a center. So if you have a point particle going in an orbit around a center, there needs to be a force on that particle which is always pulling it towards the center. This force is called centripetal force, which actually means center seeking force, as you can see from the diagram. This is given as if m is the mass of the particle and v is the velocity at a given point, then centripetal force is mv squared over r, where r is the distance of the particle from the center. Now, to execute a circular motion, this centripetal force needs to be provided by some agency. In the case of Earth and satellite, this force is provided by gravitational force. However, there can be other situations. You can have an atom with charge of plus 4e at the nucleus and an electron of charge minus e going around it, and in that case the force centripetal force will be provided by the Coulomb attraction between the electron and the nucleus. So there can be various agencies for centripetal force, so there can be variations of this problem. Anyways, coming back to our problem, we know that the force is going to be provided by gravity, so Fg equals gravitational constant g, mass of one object, which is mass of Earth, mass of the other object, which is mass of satellite. Let's denote satellite quantities by sub s. So then divided by the distance between them squared, r squared. And where the very important thing, which a lot of people miss, is that this distance is re plus ds, not only ds. Okay, then as we said, centripetal force is provided by gravitational force. This gives us ms vs squared over r equals gravitational constant g me ms over r squared. So then r cancels, and interestingly ms also cancels, giving you v just equals gravitational constant mass of Earth over radius. Now this is a very important concept in physics. This is called principle of equivalence, and Einstein once called it his happiest thought. We can see that the gravitational mass cancels with what is known as inertial mass, which is here. So this is actually the logic behind Einstein's theory of general relativity. You can look it up or send me an email and we can discuss more about it. So this leads to an expression for velocity which is independent of mass. If this force was provided by some other agency, let's say electrostatic force, then this will not be possible and the velocity will actually depend on the mass of the orbiting particle. In this case, it doesn't. And it's a very deep idea in physics. Anyways, so let's say somebody asked you a simple question that I have two satellites at the same distance, but one is heavier than others, let's say 50 times heavier. What's going to be the ratio of their velocities? You can just answer 1:1 because there is no dependence of mass in this expression. Similarly, another observation is that V goes as 1 over square root R. So if somebody gives you a problem that I have two satellites of, since the mass doesn't matter, they can give you like different masses or same masses, doesn't matter. But one of them is at a distance of 3 RE, another one is at a distance of, let's say, 8 RE. And then you can figure out the ratio of their velocities. Try it on your own. Okay. So continuing with our problem, in our problem, ds is given as 4800 kilometers. So let's write down all the constants to find the expression for velocity. So g is given as 6.673 into 10 to the minus 11 Newton meter squared per kilogram squared. Now it's always important to remember the units in which the constants are given. This is very important to get the right numbers. So mass of Earth is pretty heavy, 5.98 into 10 to the 24 kilograms. Wow. Then RE, the radius of the Earth, is 6.4 into 10 to the 3 kilometer. Now immediately you see that since G is in meter, we better convert everything into meters. So this is going to be 6.4 10 to the 6 meters. And then ds, this is because 1 kilometer is 10 to the 3 meters, as we all know. ds is 4.8 into 10 to the 3 kilometer in our problem. So this becomes 4.8 into 10 to the 6 meters. Total distance r is re plus ds. This is 11.2 into 10 to the 6 meters. Okay, so let's put everything in this formula. So v equals square root of 6.673 into 10 to the minus 11 Newton meter squared per kilogram squared times 5.98 into 10 to the 24 kilograms divided by the distance 11.2 into 10 to the 6 meters. So then meter cancels meter, kilogram cancels kilogram. If you put all these numbers in a calculator, you will get 5.97 into 10 to the 3. And the remaining units are Newton per kg times meter. Now why I'm bothering with carrying all these units through is because I want to check if my expression here is correct or not. Let's say you are doing a research problem and you develop a formula of your own. You want to check if the dimensions of the final expression you have developed, or let's say you had a complicated problem where the algebra was not this simple, you carried it out through a lot of steps. You want to make sure that the final expression you got has the correct dimensions of the quantity you are after. Okay, so that's why it's important to check the units for an important problem if it contains a lot of marks in your exam, for example. So Newton is the unit of force. Force is mass times acceleration. So Newton, unit of force, unit of mass is kg, unit of acceleration is meter per second squared. So we can put these things back. So velocity is going to be 5.97 times 10 to the 3. Newton is kg meter per second squared times meter, and we have a kg in the denominator. So kg gets cancelled. These meters squared per second squared. So this will just be 5.97 times 10 to the 3 meter per second. I understand then this is a bit of extra work, but as I said, if the problem is important enough, then it's always good to check the units. It's a physicist way of doing things. Okay, now let's say the other limit where you are actually trying to solve a multiple choice question where you have multiple choices. You don't need to get an exact answer, but any number close to it will suffice. So the first order of thing is to approximate all the numbers. So in approximation, you can write this expression as 6.67 can be just 7, then 10 to the minus 11, then times 5.98 can just be 6 times 10 to the 24, and then 11.2 can be just 10, and then 10 to the 6. So this is equal to square root of 7 times 6, and the positive powers are 10 to the 24, negative powers are 11 plus 1 12 plus 6 18, so minus 18. So 24 minus 18 is 6. So under square root this will give us 10 to the 3, and then square root of 7 times 6. So these two numbers are very close, so it can be either square root of 6 times 6 or close to square root of 7 times 7. So basically this is going to be a number between 6 and 7 times 10 to the 3. Now you can see that in your options, if all the powers are different, just from this power you can determine the correct answer. Or if there are numbers in front of powers, if no number is close to 6 and 7, then 5.97, then you can eliminate all the other options, and without doing this complicated calculation with all the decimals, just by this simple approximation, you may be able to get at the right answer. Thanks. See you in the next video. Bye.